Welcome to this exciting lesson where we'll actually deploy our first Kubernetes cluster. Once we get this cluster deployed, we can start diving into some more Kubernetes concepts such as pods and services. So let's get this cluster up and running, shall we? I want to mention that there are other ways of deploying Tanzu Kubernetes clusters, such as using Tanzu Mission Control. But for now, we'll build a cluster by creating and applying a configuration file. The TKG service will deploy a new cluster based on this config file. Here is the configuration file that I'll use for this demo. Just like other Kubernetes manifests, one of the first configurations we'll see is the API version. As of the time of this writing, we are using v1 alpha 2 for our API versioning. You'll then notice that the kind is a Tanzu Kubernetes cluster. Remember that this is what we call workload clusters created through TKG. In the metadata section, we will need to specify the name of our cluster, and I'm calling this one Alpha Cluster since it's our first one for our training. The namespace should be the name of the vSphere namespace that the cluster will be deployed in. We called our first vSphere namespace POC, and that's represented here. The spec section defines how the cluster should look. You'll notice that in the topology we have a specified number of replicas for the control plane nodes and the node pools, or often known as worker nodes. Notice that in this configuration, we'll have a single control plane node, meaning that it will not be highly available. But there are 3 worker nodes that can be used to run our container-based workloads. The additional configurations in the config require us to gather some information before we can enter it. Look at the TKR section. TKR stands for Tanzu Kubernetes Release and really means the version of Kubernetes that you're going to be deploying. TKG provides a list of Kubernetes versions that are compatible with the TKG service, and you can look this up from the terminal. From the command line, we can run kubectl get Tanzu Kubernetes Release, and you'll see a list of versions that you can choose from. I've picked the v1.20.2 version from the list and added that to the configuration file. Now back to our config file. Let's look at the storage class. We have a storage class for both the control plane nodes and the worker nodes, and this storage class is used to provision storage to our containers. We need to provide a name here that matches one of the VMware storage policies that we assign to the vSphere namespace. We can also find the names of the storage classes from the terminal. By running kubectl get storage class, you'll see the storage class listed here matches the policy in the vCenter console. The last item we'll discuss is the VM class, and again, we need to specify a class for both control plane nodes and the worker nodes. The VM class defines the size of the virtual machines used to create the cluster. These classes come from classes assigned when we set up the namespace. We can of course list this VM class from the command line by running kubectl get VM class, where we see a list of them. I've chosen to use 2 different VM classes for the control plane nodes and the worker nodes, but you can choose what works best for you. Now that we've set up our configuration file, we can simply apply the configuration file, which submits this to the supervisor cluster's API server and begins creating the cluster. We run kubectl apply -f, and the -f stands for file, and then the name of our manifest file. Once we've submitted the file, we need to wait a bit before the cluster is ready. But we can check on the status by running kubectl get tkc, which will list our Tanzu Kubernetes clusters and their status. Once the cluster is fully deployed, we will see a ready status for our TKC. If we look in the vSphere console, we'll see our cluster listed in our POC namespace and the nodes that are part of the cluster. A single control plane and 3 worker nodes. Our cluster is deployed, so let's make sure we can interact with it so we can continue our Kubernetes training. To gain access to this cluster, we need to update our kubeconfig file with this new cluster. To do this, we just repeat our login process. We will rerun this command we used earlier, which was kubectl vsphere login -- server equals, and then the name of our control plane endpoint. Then the namespace named POC. But now we'll also add one more switch, which we haven't used before, which is -- Tanzu Kubernetes cluster name and then the name of our cluster, which is Alpha Cluster. After successfully authenticating, we'll have a new Kubernetes context in our kubeconfig file. We then need to set up our context to use this Alpha Cluster by running kubectl config use context Alpha Cluster. And if we run kubectl config current context, we see that our context is set correctly. The last thing to do is to run a Kubernetes command to see if we can perform Kubernetes operations on our new cluster. In this case, I'll list the nodes in our cluster by running kubectl get nodes. Notice the node names match what's in vCenter. Well, we did it. We finally got a Kubernetes cluster running to continue our training, and we've run our first command within that cluster to see the list of nodes. Good luck on your lab where you'll build your own Kubernetes cluster in your VMware cloud environment.